Now we are discussing about the previous remaining topic. Last class I told support vector regression. Now we are discussing briefly about discuss. Okay, let's move on to the now topic. Support vector regression. Support vector machine learning is supervised machine learning algorithm which is used for the regression as well as classification problem. So if we can use for the regression problem, then it is termed as the supervised vector regression. Supervised vector regression is the regression algorithm which works continuously variable. Below some keywords which using the support vector. Kernel function. Kernel function is used for map lower dimensional data into higher dimensional data. High planar. In general, support vector mechanism is the separated line between two classes, but VSR is the line which help to predict the continuously variable and most cover the data point. Boundary line are two lines apart from the hyperplane which create a margin of the data point. Support vector are the data point which are nearest to the hyperplane and opposite classes. In SVR, we are always try to determine a hyperplane with a maximum margin. So the maximum number of data points are covered in the margin. The main goal of SVR is to consider the maximum data point within the boundary line and the hyperline. Best fit line must contain the maximum number of data point. This is the support vector regression, the model graph. You can see it. This the blue line is called the hyperline. This is the hyperline, and another two lines are the boundary lines. I already told you boundary lines. Then we are moving the decision tree regression. Decision tree regression is the supervised learning algorithm which can be used to solve both classification and regression problem. It can solve the problem for both the categorical value and the numerical data. The decision tree regression builds a tree-like structure in which each internal node represents a test for the attribute each branch. The result of the test and each left node represent a final decision or result. A decision tree is constructed starting from root node or parent node dataset, which is split into the left or right children node. Subset are the subdata. The children node are feature divided into their children's node and themselves become the parent node for those node considered below the image. This is the root node. They are divided in the children node. After marriage, this is the root node for this root. Luxury car is the children node. This is the root for the marriage. Okay. Above the image showing the example of decision tree regression. This model is trying to predict the choice of the person between sports car or luxury car. Then we are going to the random forest. Random forest is the one of the most powerful supervised learning algorithm which we are capable to performing the regression as well as the classification task. The random forest regression is the ensemble learning method which combines multiple decision tree and predict the final output based on the average each tree of the output. The combination decision tree are called as the based node model, and it can be represented a model form as this is g of x equal to f naught of x plus f of 1 plus x f of 2 of x plus dot etc. is going on. Then in a random forest using the Babbing or bootstrap regression technique or ensemble the linear in which aggregated two decision tree run is parallel and do not interact with each other. With help the random forest regression, we can prevent overfitting the model by creating the random subforest of the data. This is the test data. This is the tree 1, T2, T3, T and up to 1. And I want to need predict P this one this node. I want this predict this node. This is predict node. All average predictor. The average all predictor is called the random forest prediction. Then we are moving the rigid regression. Rigid regression is the one of the most robust version of the linear regression is smallest amount of biases. In intro to some, we get the better longest term prediction. Amount of biases, the adding the model is known as the rigid regression penalty. We can compute the penalty termed by the multiplying with the lambda to the squared weight of the each individual features. The equation of the rigid regression will be L of x equal to x comma y is equal to minimum sigma is equal to n of I is equal to 1 y of I minus w of I x of I is equal to whole square plus lambda sigma n I under I equal to n w is equal to square. The general linear or polynomial regression will fail if there is the high collinearity between independent variables. To solve such program, rigid regression can be used. Rigid regression is a regression technique which we use to reduce the complexity of the model. It is also the L2 regularization and help to solve the problem if we have two more parameters that's the same. Then we are moving the lasso regression. Lasso regression is the another regularization technique to reduce the complexity of the model. It is similar to the rigid regression except that the penalty terms contain only absolute weight instead of the square of the weight. Since it takes absolute value, hence it can mistake the slopes to 2, whereas rigid regression can stick into near as 2. It is also called L1 regulation. In the equation of the lasso will be L of x comma y is equal to minimum sigma n I to 1 y I is equal to w I x of I is equal to whole square plus sigma plus lambda sigma is equal to n I is equal to 1 w is equal to 1. This is the compare of the this is whole square, this is the normal modulation method. This is the difference between rigid regression and lasso regression. Next we are going to linear regression in machine learning. Linear regression is the one of the earliest and most popular regression machine learning algorithm. It is the statically method that is used to predict analysis. Linear regression makes predicts from the continuously or real or numerical values such as scale, sales, salary, age, product, price, etc. Linear regression shows the linear relationship between the dependent and the one or more independent variable. Hence is the linear regression. Since linear regression shows the relationship between which means is the how to find the dependent variable changing according to the independent variables. The linear regression model provides a slope straight line represents a relationship between the values. This is the here mentioned that this is the straight line. This is mentioned as the dependent variable. Okay, this line is represents a regression. This is the data set. This is the data point. X is equal to independent variable, y is equal to dependent variable. The mathematically we represent as the y is equal to a0 plus a1 into x plus sigma. Here y is equal to dependent variable, target variable. X is equal to independent variable, that is the predictor variable. A0 is equal to interrupt of the line. A1 is equal to linear regression coefficient, for example scale for input value. E is equal to random error. The value of the x and y variable are training data set of the regression represent. Types of the linear regression. There are divided into two types. One is simple linear regression and another one is multilinear regression. First we are discussing about simple linear regression. If a single independent variable used to predict the value of numerical dependent variable, then such a linear regression also is called simple linear regression. Multilinear regression. If more than one independent variable used to predict the numerical dependent variable, such a linear regression is called multilinear regression. Multilinear line. What is meant by multilinear line? A multilinear line is showing the relationship between dependent and independent variable is called linear line, regression line. A regression line is also divided into two types of relations. One is positive linear relationship, another one is negative linear relation. If the dependent variable increase on the y-axis and the independent variable increase on x-axis, then such a relationship is termed as the positive relationship. For see this graph, this is x, this is the y, this line is represent a positive line regression. The line will be explained as y is equal to a naught plus a1 into x, the negative linear regression. If the independent variable decrease on the y-axis and the independent and the variable increase on the x-axis, such a relationship is called the linear regression, negative linear relationship. This is a diagram for better understanding. I put there. Then finding the best fit line. When working the linear regression or other main goal into the fitting best line, that means the error between predict value and the actual value should be minimized. The best fit line will be least error. The different value of weights or the coefficient line a0 plus a1, it give a different line of regression. So we need to calculate the best value of a0 and a1 to find the best fit line to calculate the use of cost function. Then we are going to move over cost function. What is cost function? The cost function is divided into two values, weights or coefficient. It gives the different line of regression, and the cost function is to estimate the value or the coefficient for the best fit line. The cost function optimizes the regression, coefficient or weight. It measures how a linear regression is performing. We can use the cost function to predict accurately to mapping the function, which maps the input variable to the output variable. This mapping function is called hypothesis function. For the linear regression, we use the mean squared error, that is MSE. Cost function, which is the average squared error occurred between the predictor value and the actual value. This is the formula for mean squared error, MSE. Here n is equal to capital N is equal to total number of observation, y is equal to actual value, a1 x of I plus a naught is equal to predictor value. Redisal, the difference between actual value and predictor value is called redisal. If the observed point are far from the regression line, then the redisal will high, so the cost function will high. If the scatter point closer in the regression line, the reduction will small the cost point. Then gradient descent. The gradient descent used to minimize the MSL by calculating the gradient cost of function. The regression model uses gradient descent to update the coefficient of the line, reducing the cost function. If done by the random section, the value of coefficient and relative updates of value reach the minimum cost of function. Then we are moving to the model performing. The goodness of the fit determine how to line regression fits the set of observation. The process of the finding the best model of the output variable depends on the optimization it achieves the model. Okay friends, today I will discuss about model graph. We will meet our next video. Thank you.